Hello there. I have a question here on differentiation. It says differentiate with regard to x. Y equal to bracket of x squared minus 1. Another bracket of x cubed plus 1. Now, this question, as I've seen it, I can use two methods to approach it. I can make use of product rule to approach the question, get a particular answer, and I can as well make use of expansion of this bracket, then simplify the y, the x in polynomial form. So I'm going to try the two methods now. So let's go. I have the product rule first. I'm going to make use of product rule first. Product rule, which says the y, the x is equal to v du dx plus u dv dx. Now, y is equal to, according to what I have there, s squared minus 1 and s cubed plus 1. This is my u. Don't forget, I have told you, you mention it alphabetically. And this is my v. So, I can now say that u is equal to s squared minus 1. Then, the u, the x, will be equal to 2x. You can see, it's only this one you differentiate. 2x. Then, my v, let me underline that place. My v is equal to s cubed plus 1. Then my dv dx will be equal to 3x squared. 3x squared. So that is my dv dx as well. So I've been able to get my du dx and the v dx. Then I can now apply my product rule, which is saying the y dx will be equal to v du dx, v du dx plus u dv dx. What is my v now? The value of my v is v is s cubed plus 1. The u dx, what's the u dx? That's 2x plus u the v dx. What's the value of my u? My u is s squared minus 1. S squared minus 1. Multiply by what? U, the v dx. The v dx is 3x squared. 3x squared. Now, I will do the expansion of this bracket. I'm going to have the y dx to become equal to 2 multiplied by x cubed. That will 2x raised to the power of 4. 2x raised to the power of 4. 2 multiplied by plus 1 plus 2x. Then plus 3x squared multiplied by x squared. That about 3x raised to the power of 4 plus 3x raised to the power of 4. Plus times minus is minus 3x squared. Minus 3x squared. Now, if you look at the terms here, this term is the same as this term here. X raised to the power of 4, x raised to the power of 4. So I can now say my dy dx is equal to 2x raised to the power of 4 plus 3x raised to the power of 4. That will be 5x raised to the power of 4 minus 3x raised to the power of 2 plus 2x. That is the answer for this question given to us. This is the answer for it. Now, I want to make use of another approach to solve the question now. Approach 2. Approach 2 now. Now, I'm going to expand this bracket. I'm having s squared minus 1, x cubed plus 1. So which is going to transform into s squared times x cubed. That will be what? X to the power of 5. So y is equal to that. Don't forget y is equal to that. X to the power of 5. S squared times plus 1 plus s squared. I've used this one to multiply these two. I come here now. Minus 1 times s cubed minus s cubed minus 1 times plus 1. That will be minus 1. So I've been able to get the value of y to be equal to this now. So I can now say that, do you have any terms that are equal to one another? No. So I can now rearrange y to be equal to x raised to the power of 5 minus x raised to the power of 3 plus x raised to the power of 2. Now, why I do that is that I want to make it to be in descending order, the power on the value of my x. Now, I can now have my dy dx now to be equal to, now I'm going to now simplify each of these terms, finding their derivatives. So I'm going to have 5x raised to the power of 4 minus 3x raised to the power of 2 plus 2x. Is it the same? 5x raised to the power of 4 minus 3x to the power of 2 plus 2x. You can see that we've been able to get the same answer. I think this is faster. But if the question says you should make use of product rule, you have to make sure you make use of it. So thanks for watching this. See you next time.